Okay, I gotta begin. Hello everybody. My name is Peter Lee. I'm the developer evangelist in the developer relations team at R3. Along with me, I have my colleague David Watt from um, on the same team, and he will be primarily answering the questions that you guys drop in the chat or QA, and help me out supporting the web workshop tonight or from the West Coast this afternoon. And today's session is a Corda certification prep workshop. So the developer relations team, we host different workshops every week, primarily on Thursday. We have two sessions. One is for the European or like the EMEA region, and also including the India region. We have that on 2:30 IST, which is like 9 o'clock in the morning for London time. And then the second session is for the US time. So we are still, adjusting whether we should have it on 2 p.m. Eastern time or 2 p.m. Pacific time zone, because we are seeing seeing more people from the West Coast time zone. That's also like, the Eastern people get off work so they can drop in the work session with us. So actually, I gonna start a poll right now. Also like, playing with all these like interesting stuff that WebEx offers, or maybe not, because I think it doesn't allow me to do a poll. Anyway, so like drop in the chat if you want us to keep doing the US session for Pacific time zone, and we're gonna collect the feedback and then make the decision whether we have our next session, whether it's a West Coast time zone or East Coast time zone. So yeah, thanks everyone. I will actually get to in the workshop. So today is about the Corda certification prep workshop. Let me actually show you this. So it's on our Corda.net. And then if you go to develop, you will see the training plus certifications. And we also have like different good stuff here. And if you scroll down, you're gonna see here says get certified. It's $150 cheaper than the Amazon and etc. and like GCP certifications. But here it is. We also randomly give out free certification code from time to time, but not that often, not like every week or every month, but on a big occasion. For example, last week, QuarterCon, we have our a representative giving or like manager giving all the free code last week. So keep in touch with us from Twitter or LinkedIn. We're gonna announce when we will have a free certification day, or like how we're gonna handle out some of the free certifications. So if we go to the if we go to the certifications, that's have a different sections. So primarily we have this many topics. So from the beginning is more general Corda network and the Corda node, and then we will have a little bit more granular questions on the notary and the consensus protocols and the consensus mechanism. And down in the line, we have a state, contract, and flow. And lastly, we have a little bit feature-specific questions for such as Oracle or attachment. But today I'm gonna cover this is like 8 topic in 4 different sections. So hopefully I will give you guys a heads up of like what's gonna come in the certifications, and also prepare you guys to pass the exam. And also the exam is like once you buy one time, you can take as many time as you want, and then it's an open book. There's no time limit. So it's basically it's an opportunity. It's a way for us to help you to really master the Corda knowledge. So the first section, Corda network and the Corda node. So the Corda network, you see, for the sake of really making this exam prep material, I wrote all this material down. So you don't need to actually watch my entire video when our marketing sends you the recordings. You can just like pause and then take a look at the notes and then actually get to your exam or get to your study sessions. But for today's workshop, I'm gonna like read it and also like excel a little bit with the graph on the left. So that's how I'm gonna deliver this workshop. So first, a Corda network is a network of participants each running a Corda node with one or more Corda apps. So that means with my bold text and then underline text, these are the important message I want to deliver to you. So in the first one is Corda nodes can run one or more Corda apps. That means one node can participate in different business network. So secondly, Corda is a permission network and access to network is managed by the network operator. The full name called Network Identity Manager, but it used to call a doorman for a long time. We changed the name since Corda 4. And next, each node has a unique network identity which maps to a legal identity. A node identity is validated by an X509 certificate issued by the doorman, again, now called a Network Identity Manager. So what does it, so when we talk about blockchain, we talk about distributed identity, distributed ledger technology or distributed ledger network. So basically, your node need to have a legal identity that people can contact you with. So with like just if you think about standard blockchain protocol or standard blockchain network, you would think that is public key, private key, but that is very not easy to manage. If you think about most common or popular wallet like Coinbase or like Ethereum wallet or whatsoever, so they actually have logins. So those are the things stand in front of like those public key and private key. And similar for us in the Corda network, each node identity will have basically a name tag, and the name tag is in the format of X509 certificate. And the reason is also fairly simple because X509 has a lot of attribute, including like country name, locality name, common names, etc. So those are very easy to identify who you are. Go on to the next one. Each network maintains a network map, which is used to discover nodes in the network. So what does it mean? So once you are connected, you are hooked up with the network, people need to find you. So where are the information all stored? So the place is called a network map. Next one, communication between nodes is peer-to-peer and happens via advanced message queuing protocol, in short, as AMQP. You can search more about how AMQP works in our documentation site, but this is one of the highlights. So the next one is all communication between nodes are on the TLS encryption layer. So that's is like how we do security. Basically, it's a standard. But yeah, we have, you see, 6 bullet points. So, okay, I gonna give you guys a easy time on this. So those 6 bullet points are most likely gonna have a question on them, like word to word. So not necessarily 6 questions, but just those things are gonna, those are really gonna help you. Not gonna say much, but continue to the next one. So Corda node. So after we talk about network, let's talk about the component of a Corda network, which is Corda node, and then like in the next section, I gonna talk about Corda node tree. So on the left, we have a picture of what's going on with the Corda node. So on the left, you see we have a RPC layer, which is a remote procedure call layer. So what does that mean? That means so all the external information or interaction with your Corda applications has to go through the RPC layers in order to communicate with Corda node. And then on the right side, you see we have the network layer. So the network layer is how the node communicate with each other over the TLS and then using the queuing system. So inside of the node, there are on the top layer, we have a service hub. Basically, it's your housekeeper that keeps everything running. I mean, not keeps everything running, but keep everything managed for you. And then the housekeeper will primarily what's that called? Having these four mechanisms. The first one is vault service. So in non-Corda language, that's just your database service. And then this, I mean, database meaning like storing service. And then the second one is identity service. So those gonna understand and comprehend and digest the network network map, and then understand like who are the other nodes in the network. And also, the identity service also, Corda has a special feature called the confidential identity. So you can mask yourself with a confidential identity. So that identity service also sits in the like that area, and then just communicate with the other node in the network. And the next one, we have the key management. So very intuitively, the example is with a confidential identity. So the confidential identity gonna spit out a public key and then a private key. And then those all of the keys that the node manage gonna store in the key management. So the identity service is just constantly pulling information that it needs it from the key management. The key management also gonna maintain some other nodes key, like their public key, their confidential identity is public key, and yeah. And lastly is the messaging system, mechanism. So the messaging mechanism compose all the transaction and then put them send away from the AMQP system. So that's the node. Quickly explain in a small chart. So on the right, let's talk about some bullet points we list out for the Corda node. So Corda node is a node is a JVM runtime running in running the Corda software. So that's actually part of the story. If I really want to be very specific about it, so running a Corda node, you definitely need a JVM. However, the JVM is not solely dedicated to the Corda node because there's other things like the Artemis, and then which are the things that you need for the queuing, for the queuing. So when you set up your JVM, so I that's probably it should be a separate workshop, because I was about to say that when you configure the JVM, Corda has a minimum of 1 gigabyte requirement for the heap size and the 2 gigabyte of requirement for the RAM size. So don't just allocate one gig for heap and then 2 gig for RAM. That's not enough, because there are also like other stuff running besides the actual node in that JVM. So actually give a little bit, because otherwise you're gonna see a slow in the performance. So that's the first one. Second one, every node has a unique network identity. So in the previous slide, we talked about the node has an X509 identity, and in this one, we want you to remember every node has a unique network identity. Next one, it's like a black box which provides an abstraction for all low-level functionalities like messaging, storage, key management, etc. So that's just like what's going on in the left chart. Next one, a Corda node has two interfaces to interact with outside work. One is a network level to interact with other Corda nodes, and then the RPC layer to interact with a node operator, which is like the external user interface software. So that's also, I mentioned that. Next one, each node can run multiple core apps. That's actually is a reiteration of what I was said in the previous slide. I just want you guys to really remember it, that we have multiple questions on like business network, Corda app, how many nodes, blah, 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 blah. So make sure you look into it from the documentation. Lastly is actually operational questions. How is Corda installed? So Corda are installed on the node by placing them in the node's Corda directory. So it's very simple as that. However, the packaging procedure is a little bit complicated because it requires the node to actually sign the jar and then you place them into the Corda directory. But if you are just in the dev mode, and then in our certification, we are assuming we are in dev mode because we are still developers, not like really system operators. So for this one, it's a simple question. It's just asking like how is the core app installed? It just drop them into the directory. Sure. Next one. So let's actually test our knowledge. So how is the information shared in Corda? A, peer-to-peer base. B, by a broadcast to the Corda network. C, on a gossip protocol. D, none above. So it's it's funny that working in R3 when I actually do these kind of things, I cannot insist by just like yelling out the answer is A because yeah. So so yeah, okay. Actually, we have someone in chat trying to answer it. Yeah, thank you. So yeah, of course the answer is A. So B is more like a public network. That's not Corda. And on gossip protocol is more it's also not Corda. We don't have anything like gossip protocol. Yeah, the correct answer is A. So that's the first section about network and the node. So if you have any questions, drop in the chat, and then I think David will get it for you. Next, node tree and consensus. So those are the interesting section, but those are not confusing section, and they are actually straightforward because Corda has the easiest consensus. How would I say, easiest consensus architecture than other blockchain service. So consensus. For Corda network consensus, we have two levels of consensus is it's required. Okay, yeah, it's required in Corda. So the first level, I mean, maybe we use the wrong word. Like level, it feels like you gotta do this first and then do that second. So it's actually not. It's just like you need to have both. Like two type of consensus is required in Corda. So or like two types of consensus is guaranteed in Corda, right? So that's how I phrase it. Okay, let's actually change to types of consensus is provided in Corda. So the first layer, no, I keep using layer. So the first type is a validity consensus. So that's actually explained here as also like all transaction. Okay, so bullet point 2 is just like saying that what type of consensus we have. So we have a validity consensus, and we also have uniqueness consensus. Well, so what does it mean? So when you do a transaction in Corda, if you do everything correctly, the Corda system gonna guarantee you two things. One is your transaction is valid, and second, your proposed transaction is valid, and second, your proposed transaction is unique. That means there's no double spend. So that's under the assumption that you write your contract correctly, you write your flow correctly, you collect your signature correctly. When you do everything correctly, and then you have a transaction pass the finalization process and then record to your ledger, Corda gonna guarantee you two type of consensus: validity and uniqueness. And how is that being achieved? So let's go to bullet point 3. So this is then validity consensus is done by signers of the transaction to validate the content of the transaction. What does it mean? So before you actually running any logical executions in the network or in the ledger or in your Corda applications, you need to write your flow first. So that's your basically your execution command or instruction. And then you got to write your contract. And then in the contract, it makes sure that everything you propose in whatever transaction you have in your application, that certain transaction need to follow like a rule. Boom, boom, boom. For example, if I in the financial world, if I do a create, like I issue a token, that action is called issue, right? And then the issuance need to follow like 1, 2, 3, 4, 5 different rules, and then that's your contract rules. And then, for example, after issue, you want to transfer. So transfer is a different action. And in your contract, you're going to have a transfer as a command, literally command interface called a transfer. And then you're going to have your transfer rules, boom, 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 boom. So validity consensus is achieved because when you're actually doing a create action from your Corda node, the Corda node going to go to the contract and verify your transaction is valid, everything. And then when you do similarly, if you try to do a transfer, and then your Corda node gonna pull out the transfer contract and verify everything, make sure that your transaction is valid, that you are not proposing a malicious transaction. Okay, so that's the first type of consensus that is provided by Corda if you do everything correctly. Second one, uniqueness consensus. So this one is actually, you don't need to do anything with it because we have a mechanism called Notary. So Notary is a service that's running on your network, on your Corda network. If you are just a developer playing with a Corda network, you use the Corda application bootstrapper or Corda network bootstrapper, it will automatically bootstrap a Corda Notary in your like mock network with a simple like couple lines of configurations. So that notary will actually make sure that your input of any transaction is not double spent. So how does it achieve is the notary will keep a record or keep a list of how many like all the inputs or no all the outputs that are consumed as an input of some other transactions. So so in that way, when someone tries to spend something is already being spent, then your notary gonna say, no, you cannot spend that output again because that output is being used by a different transaction you just spent like 2 minutes ago. So that's how the Corda network provides a uniqueness consensus. Yeah, that's all. Not too much about the types of consensuses on Corda. So next one, Notary. So as I just mentioned, the Notary is a service on the network, and there are actually two types of Notary that can be run. And then when you have a multiple Notary, you want them to work together, you can have a Notary cluster as shown on the bottom left. So let's go through the simple concept or the generic concept of Notary first. So Notary, the primary purpose of Notary is to prevent double spend via uniqueness consensus. So I already explained that. So and how the Notary provides uniqueness consensus. So the next one is a Notary can be a single node or a pool of nodes having a single service identity. So that's all. That's also like what I said a little bit earlier. Is like when you have a multiple service workers, you want to group them together to do a BFT or proof of work or like Raft. You see, we have in the fifth nodes, you can have a Raft, BFT, etc. So that's when you have a Notary cluster. So if you just have a single node, you can't deploy any consensus protocol to the single node. Like it's just like whatever it says, that's a fact. So, but if you're looking to have a really working with a distrust or not like distrust environment, you can consider it. But I'm gonna be honest with you, we don't see our clients doing it at the moment because Corda is a private permission chain. It's really rare that you're gonna invite a distrust counterparty to your private chain. So just being straightforward, being like frank about it. So next, pool of Notary are often referred as a Notary cluster. Okay, we have that. Each Corda network can have one or more Notary/Notary cluster. Yes, so I give you a very simple example. The global Corda network run by the Corda Foundations not by R3, by the Corda Foundation. I mean, it sounds like we run it, but we don't. So the global Corda network has 5 notaries constantly running globally. So it's each notary probably is taking care of multiple business network. I mean, like those like not very, how would I say it? Not very uh, exhaustively. But if we have clients or customer, they want to have their private notaries, we're gonna set up a private notary for them, like privately. But for everybody, whether you are public network or private network, you can apply the easiest tier, which is the public available notaries in the Corda network. So that's just how many we have offered publicly. So similar to you. So if you can set up as many notaries as you want, as long as like you set them up correctly. And okay, maybe I say one more thing about it. So notary clusters, they work together because like those are different service worker and they have one goal is to give you a simple output. But it doesn't mean that all the notary on the same network they work together. They can work differently from different perspective. I actually think there's the questions in the chat, but I think the question is sent to the host privately. David, I don't know, are you able to see it? Mm, I mean, because I can see it. I don't know. Are you? I just don't know. Are you actually replying to them?
Everything I'm able to see, I've responded to, but
Are you able to see a message from the Ionut? IONUT.
I am not.
Okay. So uh
Yeah, sorry
oh
about that. Please paste it in the public chat. Hopefully, I can get it, or maybe Peter can get to it after.
yeah, maybe you just drop in the public chat because I think we have quite a lot of content to go through. But yeah, pasting the just make sure select send to everyone or send to panelists. Like just don't send to me because I think at the moment I can't get to it. Cool. All right, I'm gonna continue. So the next
No
one,
worries.
yeah. So the next one is each notary cluster may choose what consensus algorithm they want to run. So Raft, BFT, or like I also know that we have clients considering round robin. That means like they don't care which notary, like they do not want to do, they do not want to do basically a how would I say, like a malicious or like attack prevention consensus. They just want to make sure have a high availability notary. So they have a round robin. So each time it's a different service worker to give out the result. That's also available. Okay, so now things gonna become interesting. So I'm gonna talk about validating notaries. So as the big chart shows on the top left, notary can be validating notary and can be non-validating notary. So the non-validating notary is very simple, straightforward. Non-validating notaries only provide uniqueness because it only sees the hash of the output and then store them. And no, sorry, not store them. Like they store the consumed output hash. So when someone is trying to use the same output, they will flag them. But we also have validating notary. So validating notary means you opened up um, your transaction to the notary, and then you ask the notary to figure out if all the inputs or outputs or if the transaction is valid. So that means the notary gonna actually looking to the back chain of this transaction and then all the way to the origin of the creation of the input or the outputs. I mean, probably not the outputs, but like inputs. All the inputs see they actually have if they have the things the node claim they have. So that's validating notary. Is resource consuming because and also it's not like that cost efficient, because now basically you are saying, even though we are in the private network, I know exactly who I'm doing business with. I still don't trust them. I want my notary to make sure that all the transaction that I'm doing with him, I asked notary to check everything he claimed he has, and then I asked notary to check everything I claim I have. So that's going to provide the highest level of basically transaction validity, but it's going to slow the transaction TPS down. It's going to give the notary a lot of visibility to a transaction. So again, that's the primary reason that we don't see our clients do. And yeah, so basically validating notary is not very favored at the moment. However, thinking about 5 years, 10 years down the line, it might be, we might start seeing more clients using it, because validating notary is just truly a mechanism that's gonna get you work with a distrust party. And also, right now we are in the quarter 4.6. We have quarter 4.7 released by the end of quarter. We have quarter 5 coming. I mean, along the way, I gonna say the magic word. We're gonna have a conclave someday, hopefully soon. So conclave meaning that we're gonna have encrypted data directly working from the chip, like all the process and the calculation from the hardware level. So all the encryptions and decryptions are not from the operating system level, not from the system layer, not from the OS layer. So that means it's going to make validating notary a little bit a better option, because the notary just don't need to actually see the transaction. It can execute the calculation from the hardware level. That's a separate talk again, completely. So that's probably like a 5 hours talk. Yeah, but I think I give you a little bit details about non-validated notary and validating notary. Lastly, is details of a transaction are filtered / disclosed to the notary differently depends on the notary mode. For the non-validated notary, actually, we're gonna get to our next actual test questions, and then hopefully you guys can get it. For the validating notary, you are opening quite a lot of visibility for the transaction. So let's test our knowledge. So which part of the transaction does a non-validating notary see when signing a contract? So give a try. Our documentations are available, docs.corda.net, and then just search for non-validating notary, or like search for filter transaction. Yeah, give it a try. So not gonna hold it for too long, but 5, 4, 3, 2, 1. Okay, so that's the correct answer is A. So yeah, it's very straightforward. It's just in our documentation. So I'm not gonna give too much explanation on it, but it's just how it does. So when you're working with a non-validating notary, and then the transaction gonna get filtered. So there's a detailed explanation in the documentation, like how it's filtered, because the transaction basically is a workable tree. But what is being disclosed to the notary is the input state reference, because notary need to know. Someone says D. So the notary gonna. So the notary gonna what's that called? The notary must know, like, if this input has been consumed or not. And the second one, the time window. So that's another thing that is quite crucial with the notary, is the notary gonna give you the verdict on is your transaction still in the valid period of time. So is very common in just trading in general, like not finance trading, like in asset exchange. I mean, it sounds like I'm spitting out like fancy financial term, but if I want to borrow, like say, a book from you, right, I'm gonna promise you I'm gonna return in like 5 days. So that's a time window. So that's another thing that the notary does. The last thing is transaction notary. Of course, he gonna see himself. So people who answer these, you forget about the time window stuff. So two sections done. So we have two more. I mean, actually, just one big one and one small one. So hopefully, I can get this quick. Go through this because this is actually one of our routine workshops, which is Corda 101. So in Corda 101, we talk about Corda network, Corda node, state, contract, and flow. So if you have attended one of our sessions previously, you're gonna find this very similar. So after we talk about the Corda architecture and the system, let's talk about the Corda applications, your smart contract deployed on the Corda network. There are only three crucial things in the Corda application. First is the state, which is the object in the Corda. The object in the Corda get consumed, updated, and stored. Second, contract. What does contract do? Actually, I spent time explaining it. The contract verifies the transaction. So if all the contract rules that passed, your state get recorded to ledger. But if you don't, if you failed one of the contract rules, the ledger update proposal will get rejected. Lastly, the flow. It executes the business logic. So you can basically build out your business logic using flow. Next one, Corda state. So on the left is some highlight state that we want you guys to remember, very helpful for your exam. On the right is a simple chart that we put out to simply show that what do we mean by highlights. So first, all Corda state must implement the contract state. States are stored at the Corda vault in the node. Again, Corda. Excuse me. Again, Corda Vault is like the database in the node. Second, besides the existing Corda state interface, developer can build out their own Corda state any way they want. So if you look at the chart on the right, so we have most commonly used interface like the linear state, queryable state, schedulable state, fungible state, the ownable state. However, if you really dig into the source code, you're gonna find fungible asset basically is another sort of creation that implements both fungible state and ownable state. You can come up as many variations that you want. So you can take a look at the fungible asset state. Next one, states are stored on nodes on a need-to-know basis. So this is a little bit about how Corda architecture works. So we are, the communication is shared on the need-to-know basis. So it's a state. So that's why, like, how would I say it? But the state and the transaction is a little bit different because transaction, so basically state only stored at the its participants database. So let me put it this way, because a transaction can have multiple observers, because they are just like, can be regulator or can be a friend that you just want to show off your, newly bought like Mercedes or something. So that means transaction can actually have a broader, how would I say, channel to pass around the word, right? Like spread the information. But state, so who stores the state information? They actually own the state. So like if you have a state in your vault, that means you can spend it. So that's what I meant. So the state are stored on the node on a need-to-know basis. So you can run into some scenario is like you see the transaction, but you don't necessarily have the state. So yeah, that's what I mean. Lastly, reference state is basically a special state. It's a reference of some state you have in the database, are used when we don't want to consume the state as part of transaction. So that's again like is some scenario that you want like show people that you have it, but you don't necessarily want to consume the state at the moment or at this transaction. Maybe you just want to show him you have it at first. So it's state is very flexible. So let's test our knowledge. What fields does Corda contracts interface define? So I just what time is it? We actually it's already 5:45. So yeah, so I just gonna quickly go through this. So the correct answer is C. So what does it mean? So the participant are the nodes, or the participant are the people or the identity who gonna store the Corda contract state. So that's actually go back to the third point I was talking about. Is like Corda state only store on a need to know basis. Like what do you mean by need to know basis? So there's an attribute in the Corda state is a mandatory attribute called participant. So any identity you put in as a participant, those are the people who gonna store the state. Yeah. So next, Corda contract. So the ledger update is done through the transaction in the flow. So contract verifies the validity of the transaction. So that's, actually go back to with what we talk about is the two types of consensus in Corda. So, and the picture you see is actually an entire transaction. You have an input, which is the existing state. You have output, which is the desired output state. How you get output state is through some calculations. You encapsulate them into a transaction, and that transaction needs to go through some contract rules. On a good day, all the contract rules pass, and then you will have a ledger. Excuse me. You're gonna have a ledger update and record it to your network. So that was the highlight, and then now we want look at some notes. I want you guys to write down to pass the exam. So first, contract code are deployed on every node of a business network which use the same Corda. So we specifically say that contract code are deployed on every node of a business network. That means contract is something that every participant in the same network should have. Second, contract assures the validity of a transaction and represents a set of constraints that governs the evolutions of a state object. So that's basically a longer version of contract state assures the validity of transaction and then what you can do with your state object. The third one, transactions are verified at both initiator and the responder node. So that's actually, again, we talk about it at validity consensus section, that how we provide validity consensus from both aspects, the initiator or responder. Next one, contract has a command interface to distinguish the intents of the transaction. Commands are required in transaction. So that's also I talk about it in the validity consensus is the contract will have a special interface that records the intents of your transaction, and then different intents gonna have the different contract rules. Those are all implemented in the contract. Lastly, a command always has one or more signers. So that's pretty straightforward because the one or more signers gonna be either the executor or the responder of the command. If it's a very complicated command, you're gonna have a more signer. So quickly test our knowledge. How is contract code are represented in the Corda transaction? So you may feel like we only teach you the easy stuff, but easy knowledge, but they give you a hard question. But but this is the way we want to show you that this is a Corda developer certification. So it's not just you can do some Google search, then you can pass it. We do want you to understand what's going on from the engineering level. So yeah, so the first question, the contract jar file is attached. Second Corda transaction does not contain any information of the contract. Third, C, the contract jar's hash or hashes are attached in the transaction. D, none above. So the correct answer is C. Yes. So Antonio got it right. So that's how you actually that's how the transaction how the contract is represented in the transaction. That's actually like when you look at the database, when you do when you start your node, you do a transaction and then you type your command run internal verified transaction snapshot. You can see your input, output, other information, and then you are also gonna see attachment. So if you have like no attachment in your transaction, like no real attachment, you still gonna see a hash. So that hash is your contract jar. So that's how a contract or a contract jar is referenced in a transaction, in every transaction. And when you have a real attachment like a PDF or a text file, you're gonna see two attachment hashes. Then you gotta figure out which one is your real file. So typically starting from the second one. Cool. Lastly, flow section. So for flow section, flow is a mechanism that executes the business logic. And on the screen here, we also like just give you a very simple representation of a two-node, one-notary flow. So I'm not going into detail of it because we have a Corda 101 covering this. But I just want to give you guys some highlights to draw down and then think about it. So on the left, so this is basically what you actually do in the flow. So from the start, you building the transaction, meaning you build like query the input or build out the input and then build out the output with the input reference whatsoever. And then you verify the transaction by run the verify method. That's the node gonna automatically pull the contract code, and then you sign it, or you and also you sign to you send to your counterparty. Your counterparty signs it, and then those are the collecting signature section. And then lastly is a record. The record is a little bit more automated. So you just call the method called finality flow. So the finality flow will take your transaction to Notary, check for double spend, and then coming back, broadcast to your counterparty, and then do a ledger update. So those are the things you have in the flow. So let's look at the nodes. So flow automates the process of agreeing ledger updates. That's what I said actually. Flow normally goes in pair, one initiator and one responder. Yes, because that's I would actually, I'm just like thinking it's in specific details. Is there a way that, like I say, flow must go in pair? It's not necessarily true, because flow can also do single node execution. But okay, then let me put it this way. So if you have a transaction between multiple parties or multiple nodes, then flow normally goes in pair, one initiator and one responder, because the other party need to respond to your whatever request. But if you just try to like update something in your own node, yeah, I think I got double check, but I think flow can be run without an initiator, but it's not necessarily all the time. So third one, the party which initiated flow is most likely responsible for creating the output state that are proposed change to the ledger. Yes, that's true, because the initiator normally builds out the transaction and then make it as a proposal to the counterparty. Lastly, Corda flow guarantees eventual finality. So you know, it feels like I'm saying this very casually, but a lot of people don't realize how important this is. So we're in high-valued market. We're in a high-valued industry, whether it's insurance, finance, or whatsoever. Those clients, they want finality. So whether people think about Bitcoin or Ethereum, how people think about finality is like, okay, after 7 blocks, most likely the Bitcoin the transaction on the Bitcoin chain is finalized. That's not actually true because there's like slight 0.00001 chance there someone can outcompete outcompete the computation in the next block and then revert the whole damn thing. So there's a slight chance. So as long as there's a chance, it's not eventual finality. But with Corda, it's guaranteed it's finalized because we just don't offer the possibility of what's that called? Revert. It's a total immutability. So let's test our knowledge. What annotation does a flow need to trigger? What annotation does a flow need to be triggered from an RPC call? So again, I'm gonna be quite honest. It's like this is a developer certification, so we're gonna have code questions for this. So the answer is C. Startable by RPC. It's very intuitive. So our code is very straightforward. We don't meant to trick you. So yeah, it's C. The next section is Oracle. So I was hesitate to put up this detail-oriented features for the prep course, but my colleagues insist we also talk about it. So let's talk about it very quickly. So Corda also support Oracle. So what is Oracle? So Oracle is a trusted third-party information source which provides off-ledger data to blockchain network. So if you think about Oracle's after you know it, the question is like, why do you need Oracle? So Corda is a total deterministic environment. So that means contract code cannot depend on non-deterministic information source, since all parties must be able to verify a transaction and come to identical conclusion. That means, for example, if I say right now it's raining in New York and David lives in a different state, right? And he gonna say, wait a minute, I don't know. Right? Like if I look outside, we don't have the single source of truth. So then how we do it? We might look at weather.com, right? If we treat it as an oracle. So the same thing goes on here is what we are working with our clients from high valued industries. So for example, the foreign exchange rates. Like I say right now, the US dollar to Canadian dollar is like $2. Nobody believes me. Like that's exactly right because people believe in authentic foreign exchange rate. So that's the reason. So we have this feature available on Corda. A lot of our clients use it, and we have not so many, I think 5 questions on Oracle. So we have a good documentation on it. So any people who have questions, they can just read the documentation. So look at the highlights here. So yeah. Second one is contract code valid at one instance should be valid in another to maintain integrity of the ledger. So that's basically what's Oracle and why we need it. And that's it. So okay, but like not too long for the second note, but because I want to show you one more thing. So the last section of the certification is code questions. It's not actually coding questions, but it's code questions because we want you to actually look at our code. We just don't want you to do some Google search, read some documentation, and then go out and then claim you're Corda developer. So we have some questions like this. For example, in these samples, in this what's that called? In this file, in this responder of the initiator, I'm skipping a lot of stuff. But the question is, what's the flow exceptions that is flowing? So you see, it might sound a little dumb that we just like put a very simple questions, but yeah, that's our intuition. We want the real developers to pass the certification, and we also want people to actually go into our code and then really learn it. So Yeah, so for this question, what does exactly this measure called the modification flow responder do? The modification responders make sure only the proposee can modify the proposed. If you are not the proposee, then you cannot modify the proposal. So yeah, those will be like you're gonna see question like this. Not that's like super difficult, but as long as you can comprehend the code, you are good to go. So yeah, that's all for the day. It's exactly 1 hour. Thank you, everyone. Hope you guys learned something useful today, and hopefully you pass the exam. Also, you can reach out to us by Devrel@r3.com. Me personally, Peter.Lee at r3.com. And David is also in the channel showing like how you can reach out to us is slack.corda.net. And make sure keep in touch with and keep like following what's news coming to the community from Corda.net. Thank you, everyone. My name is Peter Lee. Have a good rest of the evening. Bye.